Okay, 6.3 gravitational potential energy in general. So you know gravitational potential energy is m2h, and the force is g, gravitational constant, mass of the earth, mass of the object, divided by r power 2, right? Knowing that potential, that was, make sure everyone, this is potential energy, right? So we know the area under the force displacement, it would give you the potential. So if you find that area, you will find out that the area is Gm and R1 minus Gm and R2. Okay. So final minus initial. Make sure this potential are negative. So changing potential is negative Gm and R2 minus negative Gm and R1. Final minus initial. The thing is that we consider the potential at infinity to be 0. Of course, just imagine this is the Earth and an object at infinity. It's very far, so it doesn't feel any force from Earth, right? So the potential here will be 0 approximately if this is very, very far, right? That's why, look at this picture, at very far, this potential curve going to 0. And when it's very close to the object, it's going to very much more bigger. So here is again the equation. Just look at that example. What is the change in gravitational potential energy of 64.5 kilogram astronaut lifted from Earth into circular orbit of altitude 4.4? And I said altitude means distance from the person and the center is altitude plus the radius of the Earth. So R2 is just the R Earth plus that altitude is given at the, that would be the final position. Initial point is at the surface, means this is the radius of the Earth. So knowing the potential energy is G gravitational constant, multiplied mass of the Earth, mass of the object, R, distance between the object and the center of the Earth. So at the beginning, it is at the surface of the Earth, so you just put the RE, and then you know the rest of that, mass of the person, mass of the Earth, and G, you just find that and make sure this is negative. And then you find the EG2, and then it is at the position of the 6.82 to the power 6. The rest of the constant you know here. If you find it, then the EG2 minus EG1 final minus initial will give you the difference, the potential change, energy change here. And as you see, you can do it using mg delta y. Just delta y is y2 minus y will give you 2.8 10 power. As you see, this is much more accurate because here the G we consider for these two positions to be the same, right? But you know, in reality, G would be different. So this answer is much more accurate. Again, the question 1, 2, 3 for this.